in. So what we want is basically we have time down here. So we have baseline and how many minutes?
15.
Not
50 is 15%.
15%.
Yeah.
So how many minutes? How many stages did he get through? So let's call this stage. In every stage.
6.
No. Give me that dish. So what was the time on the treadmill that we started? Was it 5 minutes or 4 minutes? Started at 5 minutes.
Yeah, I missed
Okay.
it on my part.
So we made it through almost 15 stages. Okay. So can I just have this for a few minutes?
Yeah, sure.
Okay. Okay, so we had incline at each stage, and his last incline was 15%. So this was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there was no stage 15. Okay? And then his heart rate at each minute was, let's see, we went 85, 125, 137, 138, 151, 156, 160, 159, 175, 157, 183, 188, 180, 191, 194. So just go with 194. All right. Then his lactate at 0 was 2.9. At 2, so at 2 minutes, it was, so let's see here. We took a lactate at 2, took a lactate at 4, took a lactate at 6, took a lactate at 8. Then I wanted to wait an extra minute, so we took a lactate at 9, 10. This was actually at 11. And then we had a lactate at 13. Okay? Or actually, we had a lactate at the end. Okay. Ignore this one. Okay. So at 4, his lactate was 3.6. At 6, his lactate was 5.5. At 8, his lactate was 3.6. I lied. So we had 2.9 was baseline. How do I... Sorry. So his baseline was 2.9. His at 2, he was 3.6. At 4, he was 5.5. At 6, he was 3.6. At 8, he was 6.7. And then at 11, he was 12.3. Okay? At the end, he was already starting to come down. He was 9.0. So you don't really have to... This is the one that's going to give us our lactate threshold. Understand?
How does he
Okay. Then VO2 at, let's see here, we started at, what was, 0 was 5 minutes. So that's 300 seconds. Is that true? 60 times 5 is 300? Okay. So we started, his VO2 was 15 at 2 minutes in. So let's see here. That means 330. How many seconds is 2 minutes? 120. Right? So
Yes.
420, it was 29. Then at 540, it was also 29. At 660, it was 31. At 780, it was 32. And at, would that be 900 plus 60 more? It was 35 at the end. Okay, so VO2 did go up. If I had to guess, I would say your VO2 max is over 35. Like, I think it would have made a difference if we had had the bigger mouthpiece on.
Well, it seemed like I wasn't getting out.
Getting it, yeah, okay. Okay, so everybody, this is your data from this lab. For your lab report, you need to do work at each stage. And you do realize you can just put the work equation into Excel for one of them and draw it down for all the other factors once you have it worked out, right? But it also means you're going to have to take the speed in miles per hour and convert it to meters per minute, and then figure out the slope and calculate vertical distance per stage. Okay? And then you'll know what the workload is over that 1 minute or 2 minute mark. Understand? Okay? Then, can I delete this? People have this written down? Took pictures of it? Whatever you're going to do to record it?
What is under slope again? Sorry.
The vertical distance covered.
Okay.
Okay? So then you want down here to be time and incline. So you're really only going to be able to use time as your x-axis, but then you can go in below it on your figure and write in which incline it was, right? But time and incline are basically going to be the same, right? Except that at 0, we were already at a 1% incline from 0 to 1. So you could just use incline. Now, for everybody, don't forget that we did 6 miles per hour the entire time. So speed is not something that we have to chart. Do you understand? Because speed stayed constant. Incline goes up. So this is going to be, we started at 1, 2, 3, 4, 5, etc. Right? And then you should have a graph that looks at heart rate, go up like this. And then you should have a graph that looks at VO2 every 2 minutes, which kind of goes up like this. And with your data points for every 2 minutes for lactate. And when it goes, it's going to creep up around 6, and then it shoots up to 12. You understand?
So if we're doing every 2 minutes and you want every single stage, what is it going to be like when?
Just blank squares.
Okay. Gotcha.
It'll just be blank squares. Now, what I would recommend is that just for confusion, so that you don't get confused, you make one of these for heart rate versus incline.
And then you put them together.
You make one for lactate versus incline, or time. And then you make one for VO2. based on incline or time. Okay? And then what I want is for you, the lactate one's going to look like this, the heart rate one's going to look like this, and the VO2 one is going to look like that. Do you understand? So what I want you to do is go to your lactate one and draw a line where it goes exponential, where it really starts to break. Okay? And then we'll do then drop down and figure out what time that was at. Go up to that time here and on that time here, and then draw up and figure out what the VO2 was and what the heart rate was at his lactate threshold. And how you would use this functionally is that you would say, all right, Trenton, I want you to go and do a hike at 60% of your lactate threshold. You know what heart rate his lactate threshold is, so then you can figure out what his heart rate would be at 60% of that. Or you actually look at 60% of his lactate threshold, and then you figure out what the heart rate would be, right? So we have now all these variables to where we can set workloads for him based on that. Okay? Really important. The last thing is that one of the goal then with a training program would be that if on 4/16 his lactate threshold was this, that say on September or October 16th, 6 months down the road, his lactate threshold is now like this. So you want to try and flatten this curve so that this is all added buffering capacity, which means he's going to be able to produce more work before his lactate shoots up. You understand? Okay. Thanks a lot. You guys did awesome. Thank you, Trenton. That was awesome. You did a really good job, and I really appreciate